Hi everyone, this is Anil Kumar. I am working as an assistant professor in the Department of ECE in Marri Laxman Reddy Institute of Technology and Management. Today's our subject is embedded system design. In that, we are going to discuss the topic is classifications of embedded system. Mainly, we are having four types of classifications. It is classified based on different criteria. First one is based on generation. Second one is complexity and performance requirements. Third one is based on deterministic behavior. Fourth one is based on triggering. Classifications based on generation. In that, we're having four types of generations. They are first generation, second generation, third generation, and fourth generation. First generation. Coming to first generation, the embedded system built around 8-bit microprocessor and 4-bit microcontrollers. First generation, see here, 8-bit microprocessors and 4-bit microcontrollers. In the first generation embedded system designed with built around 8-bit microprocessors and 4-bit microcontrollers, as well as these is simple hardware circuits with firmware development in assembly code. In first generation, the hardware circuits is firmware developed in assembly code, simple hardware circuits with firmware. Firmware in the sense it is a software code. Software developed in assembly code. Coming to exams, digital telephone keypads, stepper motor control units. In first generation, we are going to take examples as digital telephone keypads. This is digital telephone keypads. Earlier days were used stepper motor control units, etc. Coming to first generation examples. Second generation, it is built around 16-bit microprocessors and 8-bit microcontrollers. It is built around 16-bit microprocessors and 8-bit microcontrollers. It is double to the first generation. As we said, first generation, 8-bit microprocessors and 4-bit microcontrollers. But here, double to the first generation, 16-bit microprocessors and 8-bit microcontrollers. The instruction set for the first and second generation process controllers were more complex. As compared to first generation, the microprocessors controllers were more complex and powerful than the first generation. Coming to examples, data acquisition systems, SCAD systems, etc. for the second generation examples. It is more complex as compared to first generation. Coming to third generation, it is built around 32-bit microprocessors and 16-bit microcontrollers. It is also twice to the second generation. First, we are used before that 16 in second generation. Before that, we are used 8-bit microprocessors. In that, first we are used in second generation 8-bit microcontrollers, 4-bit microcontroller in first generation. We are observing twice of the generation. We are upgrading the generation. When we are upgrading the generation, also upgrading na, at that time we are updated the system, embedded system. We are updating twice to the first generation to second generation and second generation to third generation. We are upgrading the generation. Here we are used DSP ASICs, digital signal process, as well as application specific integrated circuits. Why we are using means ASICs means for a specific task. As we know, embedded system is nothing but the combination of hardware and software for a specific task, for a specific use only. As like that, we are used DSPs ASICs for in third generation. As well as the instruction set of process became more complex and powerful, and the concept of pipeline also evolved. The instruction set of process became more complex and powerful as compared to first generation and second generation. In this third generation, the instruction set of process became more complex and more powerful. And the concept of pipelining also evolved. Pipelining is nothing but transferring the data from one end to another end in the large data from long distances to overcome any errors, any bugs, any disturbances occur. We are coming to know by using pipelining. So we are using in third generation pipelining. Examples, coming to examples, robotics for third generation. Coming to fourth generation, it is built around 64-bit microprocessors and 32-bit microcontrollers. We can observe here also twice to the third generation. Here also before we are used here 32, twice to the third generation 64, as well as here also 32-bit means 16-bit microcontroller in third generation into 2, twice to the third generation it is going to 32-bit microcontroller. The concept of system on chips, SoCs, and multi-core process, Intel Core i9 involved in this fourth generation. Concept of system on chips, SoCs. That is, system on chips means SoCs. And a multi-core process. Multi-core process we are using in Intel Core i9 evolved in this fourth generation. This is high complex and very powerful as compared to first generation, second generation, third generation. This is high complex and very powerful as compared to before three generations. Examples, coming to examples, smartphone devices, mobile internet devices, that is MIDs, etc. These smartphone devices as well as mobile internet devices are the examples for the fourth generation. We are using upgraded version only, that is fourth generation. We are all are observing smartphone devices, that is how the smartphone is actively working towards mobile internet devices, MIDs, all are observing in the present generation, that is fourth generation. This is about the generations of embedded system, that is based on generation. And classification based on complexity and performance. In this, we are having three types of generations. There are three types of classifications. They are small, medium, large. Small scale embedded systems, medium scale embedded systems, large scale embedded systems. We are going to discuss about these three types. They are small scale embedded systems. In small scale embedded system, we are observed it is simple to design. In small scale embedded system, this is simple to design and performance not time critical. In this small scale embedded system, performance not time critical. These are built around low performance and low cost. These are the built around low performance. If small scale, it is low performance and low cost. We are using in this 8 or 16-bit microprocessors or microcontrollers. We are using here 8 or 16-bit microprocessor or else microcontrollers. In this may or may not contain an OS. In this small scale embedded systems may or may not contain an operating system. Coming to examples, electronic toys, smart cards. This is the smart card example. Okay, this is a small scale embedded system classification. Next, medium scale embedded systems. These are slightly complex in hardware and firmware as compared to before small scale. In medium scale, these are slightly complex and hardware and firmware. In hardware and firmware, medium performance. In this classification, we are going to take 16 or 32-bit microprocessors or else microcontrollers, controllers or DSPs, ASICs. DSPs means digital signal process as well as application specific integrated circuits for ASICs. As OS, that is RTOS. In this, we are having operating system that is in the form of RTOS. RTOS means real time operating system. The main programming tools used for these systems include C, C++, Java, Visual C, C++, RTOS, etc. These are the programming tools we are using in the medium scale embedded system. Examples, coming to examples, ATMs, that is automatic teller machines, automated navigation systems, home appliances, and medical devices. These are the examples for the medium scale embedded system. And in second generation classification, large scale embedded systems. This is high complex hardware and firmware. As we compared for both the previous small scale, medium scale, these large scale embedded systems, this high complex as well as high complex in hardware and firmware. We are going to take 32 or 64-bit RISC processors or controllers or multi-core process and programmable logic devices. Here we are taking in high level of process controllers like RISC process or controllers or multi-core process or PLDs, that is programmable logic devices. High performance, it has high performance autos. We are having here high performance real time operating system. The best example for the large scale embedded systems are aerospace, industrial automation, advanced robotics, wireless communication systems. This is the best example for the large scale embedded systems. Already we said high complex. In aerospace, we are going to take or use high complex hardware and firmware for the large scale, like aerospace, industrial automation, advanced robotics, wireless communication systems. These are the high complex, as we know, in embedded system. Next, based on deterministic behavior. In this, we are having two types of classification. They are soft real-time as well as hard real-time systems. In the soft real-time systems, in this type of embedded systems, deadline is not strictly followed. In soft real-time systems, embedded systems, deadline is not strictly followed. That is no need to use deadline or follow the rules and regulations in soft real-time systems. Missing deadline for tasks are acceptable for soft real-time systems. If a deadline is missed in soft real-time, that is acceptable. Examples are ATM machines. In this case, a late answer is an acceptable answer for the soft real-time systems. How means, if we are went to withdraw the cash from the ATM machine, if then error will be occurred at that time, that is not a that means not that much of problem we are going to face in soft real-time systems. If we lose little bit of money or else any disturbances occurred, but that is not that much of disturbances for us. Example is ATM machine in this case. Going to second classification, hard real-time systems. In hard real-time systems, a hard real-time system must meet the timing deadlines without any delay. In hard real-time, there is no without any delay, the timing deadline will be there. Must meet the timing deadline without any delay. In soft real-time, any delay will be there, that is also acceptable. But for in soft real-time system, but in hard real-time systems, must meet the timing deadlines without any delay. Missing the deadline would cause serious failure to the system or user. User means human being. For example, the airbag control systems, a late answer is always effectable. Why means, if any accident will be occurred, any collision will be happen in between the two vehicles, at that time the airbag will be react as soon as possible. Otherwise, the human lives will be lost or else property damage will be occurred. So, missing the deadline would cause serious failure to the system or user. Next, final one is based on triggering. These are also two types. The embedded systems are classified into two types based on the triggering of the systems. They are time triggered and event triggered. These based on triggering, we are having two types. They are time triggered as well as event triggered. Time triggered. If a system is activated or triggered based on the predefined task or preset time, then such a system is said to be the time triggered embedded systems. In time triggered, what we said, predefined task or preset time before we are given the task to the system, predefined task or else preset time before going to the task. This is time triggered. Okay. Next, event triggered. If the system is triggered based on some activity like changes in temperature or changes in pressure, such system is said to be an event triggered embedded in embedded systems. This is if the system is triggered based on some activity on that situation, that on that event, that changes will be occurred like in event trigger. But in time trigger, we have to give predefined task to that system or else preset that time to that system. But in event trigger, that not happened. So this is a time trigger, this is event trigger. This is all about the classifications of embedded systems. Thank you.